Hi all, welcome to new class. Today's class is about electrical analogues of mechanical translational systems. The electrical analog of any other kind of system is of great importance since it is easier to construct electrical models and analyze them. The three basic elements mass, dashpot and spring are used in modeling mechanical translational systems are analogous to resistance, inductance and capacitance of electrical system. The input force in mechanical system is analogous to either voltage source or current source in electrical systems, and the output velocity in mechanical system is analogous to either current or voltage in an element in electrical system. Since the electrical systems has two types of inputs, either voltage or current source, there are two types of analogies: force voltage analogy and force current analogy. First one is force voltage analogy. The force balance equations of mechanical elements and their analogous electrical elements in force voltage analogy are shown in this table. So here in mechanical system input is force and output is velocity, and in electrical system input is voltage source. So in force voltage analogy input is force voltage source and output is current through the element. So the force is analogous to voltage source and velocity is analogous to current through the element. And here the displacement x is analogous to charge q in electrical system. And also here, considering the dashpot, f is equal to b into dx by dt, and that is equal to b into v, where v is the velocity. And similarly in electrical system we have E, the voltage is equal to R into I. So here the frictional coefficient of dashpot B is analogous to resistance R in electrical system. And while considering the mass M, we have F is equal to m into d square x by dt square, and also we can write m into dv by dt. That is acceleration A is equal to d square x by dt square, and that is equal to dv by dt. Similarly in electrical system we can write, in the case of inductor, E is equal to L into di by dt. So the mass M is analogous to inductance L in electrical system. And next is spring. So here F is equal to K into X, where K is the stiffness of spring, and we can write K into integral V dt. That is X is equal to integral V dt, where V is the velocity. And in electrical system, in the case of capacitor, we have E is equal to 1 by C integral I dt. So the stiffness of spring K is analogous to the reciprocal of capacitance, that is 1 by C. K is equal to 1 by C. So here this is the input F. Here input is voltage source. So in this way we are writing input F is equal to B into V. So similarly here input is voltage. So E is equal to R into I. So here also E is equal to L into di by dt. Here also E is equal to 1 by C integral I dt. So we can write B is analogous to resistance R. M is analogous to inductance L. Then K is analogous to 1 by C. And X is analogous to Q. Then force F is analogous to voltage source. Then velocity V is analogous to current through the element. So this is the case of force voltage analogy. Guidelines to obtain electrical analogy of mechanical system. In electrical system, the elements in series will have same current. Similarly, for mechanical system, the elements having same velocity will be in series. Second one, elements having same velocity in mechanical system should have elements having same current. Third one, each node in mechanical system corresponds to closed loop in electrical system. Fourth one, number of meshes in electrical system is equal to number of nodes in mechanical system. Fifth one, the element connected between two nodes of a mechanical system is nothing but common element between two closed loops of an electrical system. The last one is mechanical driving source, that is the force and passive elements connected to node in mechanical system is represented by analogous elements in closed loop in electrical system. Next is force current analogy. The force balance equations of mechanical elements and their analogous electrical elements in force current analogy are shown in this table. So here the force is analogous to current source, velocity is analogous to voltage across the element. The displacement x is analogous to flux phi. And here in the case of dashpot, F is equal to B into dx by dt, and that is equal to B into V. Similarly, in electrical system, we can write here input is force and here it is current. So I is equal to 1 by R into V, and this 1 by R is the conductance G. So the frictional coefficient of dashpot B is analogous to the conductance. In the case of mass, F is equal to m into d square x by dt square, and that is equal to m into dv by dt, where v is the velocity. Similarly, in the case of capacitor, we can write current I is equal to C into dv by dt. Here C is the capacitance and V is the voltage across the capacitor. So mass M is analogous to capacitance C. In the case of spring, F is equal to K into X, and that is equal to K into integral V dt. Similarly, in inductor, we can write current I is equal to 1 by L into integral V dt. Note that here V is velocity, here V is the voltage across the inductor. So, the stiffness of spring K is analogous to the reciprocal of inductance, that is 1 by L. So, in force current analogy, we can write B is analogous to G, that is conductance 1 by R. Then M is analogous to C, capacitance. K is analogous to 1 by L. And X is analogous to phi. Then force, that is input force, is analogous to current source. Then velocity V is analogous to voltage across the element. So this is the case of force current analogy. Next is the guidelines to obtain electrical analogues of mechanical systems based on force current analogy. First one is, in electrical systems, element in parallel will have same voltage. Likewise, in mechanical system, the elements having same force are said to be in parallel. Second one, the elements having same velocity in mechanical system should have analogous same voltage in electrical analogous system. Third one, each node in the mechanical system corresponds to a node in electrical system. A mass is considered as a node. Then fourth one, the number of nodes in electrical analogous is same as that of the number of nodes in mechanical system. Then fifth one, the mechanical driving sources, that is forces, and passive elements connected to the node in mechanical system should be represented by analogous elements connected to a node in electrical system. Then the last one, the element connected between two nodes in mechanical system is represented as a common element between two nodes in electrical analogous system. So this is about the force voltage and force current analogy in mechanical translational systems. So in the next class we will do problems related to this force voltage and force current analogy. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.